Okay, so we're working through some related rates examples, and the last thing we talked about was the idea of similar triangles. Oops, sorry about that. So what I think I'll do is I'll pause for a moment and write up the next example, and then we'll see where to go from there. All right, so here we have two airplanes. Two airplanes are approaching an airport. One is flying due west at 120 miles an hour, and the other plane is flying due north at 150 miles per hour. Assuming constant elevation, how fast is the distance between the two planes changing when the westbound plane is 180 miles from the airport and the northbound plane is 225 miles from the airport? Okay, how should we start? Um, the best way to start is to draw a sketch of the situation. And so if this is my airport, right, then one plane is flying west to the airport, so that must mean that the plane is over here somewhere. Oh, let me get myself a little bit of room here. That means the plane is over here somewhere, and it's flying this way, right? Okay, and so then uh, the other plane will be down here, and it's flying north. Okay, and so what you might be seeing here is already a triangle between them, right? Right triangle. And so it looks like we're going to need the Pythagorean Theorem to get a relationship between the variables and the distance, right? So let's just go ahead and maybe label this as x of t, and this will be y of t, and so this will be our z of t. Z of t then is our distance between the planes. Good. And so therefore, by the Pythagorean theorem, we get the relationship that z of t squared is equal to x of t squared plus y of t squared. Excellent. All right. Now, you could have written this as a square root, right? But I think it's easier to differentiate if you don't. Although, like I said, you can. It's going to come out the same either way. Okay, so then we have to differentiate because we're looking for what are we looking for? How fast is the distance between them changing? So we're trying to find dz over dt when what is happening? Let's see, x of t is 180, y of t is 225. What's our speed? Dx over dt, what did we say here, is 120, and the other is 150. So that means that dx over dt, see if I can keep my picture in line here, is what did I just say? 120 and 150. 120 dy over dt is 150. Good. And I think we've got all our pieces. So now we just differentiate. Okay, so solution is to differentiate everything in sight. Now notice that the related rates here is that the distance is related to the change in the legs. And so if we use our our chain rule, that'll be 2 times z of t times dz over dt is equal to, again, these are going to be two chain rules, so 2 times x of t times dx over dt plus 2 times y of t times dy over dt. And just to simplify things a little bit before we start plugging in numbers, we can get rid of the 2's, right? And now, just as a reminder, right, we're trying to find dz over dt, right? So let's plug in our numbers for everything else. So x of t is 180, dy or dx over dt is 120, y of t is 225, dy over dt is 150. So do I have values for everything? Oop, I still need a value for z, right? So what's my value for z? Well, I'm not given it, but I am given that x and y are 180 and 225, so therefore z must be equal to the square root of 180 squared plus 225 squared. Okay, and if I compute that on my calculator, I get 288. So you should have your calculator handy while you're working these. Good, and now you have all your numbers, right? Everything is known here in this equation except for dz over dt, so we can just go ahead and make our computation, and we see that dz over dt is going to be, let's see, 180. I should mention one thing. Dx over dt, what I've written up here is the speed. The speed is 120 miles an hour, but what is the velocity? Does everybody know the difference between speed and velocity? So just as a side remark here, I shouldn't have stopped, but speed is the absolute value of velocity. Okay, so in this case, is our velocity positive or negative? And you can tell because x of t is either increasing or decreasing. And so in our case, x of t is decreasing, and therefore the velocity is actually going to be minus 120. And so that's why I paused here, because this should be 180 times minus 120. You can interpret this as positive or negative later, but it's good to go ahead and put the positive and negative signs in now, just so we don't forget. Okay, and then that'll all be over 288. Good. And if we compute that, that's minus 192 miles per hour. Good. So how should we interpret that? The negative sign. The negative sign means that the distance between the planes is decreasing, and so the negative means that the distance is decreasing between the planes. So we would say that the distance is decreasing at a rate of 192 miles per hour. Very good. Okay, I think I will go ahead and stop the video here, and then we'll just create a new video for the next problem. See you then.